Hi everybody. In this video, we are going to be learning about the Pythagorean Theorem. We're going to learn how to solve right triangle problems with the Pythagorean Theorem and how to recognize common Pythagorean triples. So the Pythagorean Theorem is named after the Greek mathematician Pythagoras. However, there are records of its use in northern Africa hundreds of years before Pythagoras lived. And the Pythagorean Theorem states, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the square of the lengths of the legs. To understand that, we first need to understand what that word hypotenuse is. The hypotenuse is the segment that is across from the right angle. So no matter how we rotate our triangle, the hypotenuse will always be the one that is across or opposite the right angle. The other two sides, the ones that are touching the right angle or adjacent, we would call those our legs. And it doesn't matter which one you label A or B, they're both the legs. So this is the Pythagorean theorem in words, right? The square of the length of the hypotenuse is equal to the sum of the square of the lengths of the legs. Now, most of you, though, are more familiar seeing it as a formula. A squared plus B squared equals C squared, where A and B are going to be the legs, and C is going to be the hypotenuse. So A and B would be our legs, and C would be our hypotenuse. Now, a Pythagorean triple is just a special set of side lengths, specifically where the numbers are all positive integers, right? Integers are just your positive or negative numbers that do not have any decimals or fractions in them, or are not irrational. So in this case, positive integers would be something like 3, 4, 5. And we can prove that 3, 4, 5 is a Pythagorean triple because first off, they are all whole numbers. So they are all integers. So I'm going to check that part off. And then I want to check that A squared plus B squared does actually equal C squared. I know A and B are going to be 3 and 4 because they're always going to be the shorter sides. Your hypotenuse, by definition, is the longest side of the triangle. So if I use a calculator here, 3 squared is 9, and 4 squared is 16, and 5 squared is 25. And if I check that, 9 plus 16 is, in fact, 25. Therefore, it is a Pythagorean triple. So you know it's a Pythagorean triple because all three sides are integers, and they do satisfy the Pythagorean theorem. So you know they're integers, and they satisfy the Pythagorean theorem. We can also see if these will make a Pythagorean triple. So in this case, they don't give us the value of C. So if I write down my Pythagorean theorem, they give me A and B, which is 12. So 5 squared plus 12 squared. And then they're asking for C. Once again, I can use my calculator. This would be 25 plus 144. And that would be equal to C squared. So 25 plus 144 is 169. And I can use my calculator. C is going to be the square root of 169, which is in fact 13. This is a Pythagorean triple. I know it's a Pythagorean triple because 5, 12, and 13 are integers, right? They're all whole numbers, and they do satisfy the Pythagorean theorem. Now we can also look at two examples where they give us all three values and we see if they make a Pythagorean triple. To do my first one, I'm going to do 9 squared plus 40 squared and ask, is that equal to 41 squared? So that would be 81 plus 1600, which would be 1681. And that might be equal to 41 squared. And I can use my calculator and get that 41 squared is in fact 1681. So in this case, then they are a Pythagorean triple. But when I try this with 10, 49, and 50, let's see what happens. 10 squared plus 49 squared equals 50 squared. I know that 10 and 49 are going to be A and B because they're the smaller values. So this would be 100 plus 1401. And is that equal, 2401. And is that equal to 2500? Well, this would be 2501, which does not equal 2500. Therefore, it is not a Pythagorean triple. So that's how we identify a Pythagorean triple. We just plug the values into our Pythagorean theorem. So let's try with two examples. But in this case, we are solving for one of the legs, not one of the sides of our triangle. So if I'm setting up my formula a squared plus b squared equals c squared, I'm sorry, we're not solving for the hypotenuse, we're solving for a leg. Then I would have 9 squared plus x squared equals 11 squared. Notice that the x is replacing b in this case because it's a leg rather than the hypotenuse. Now that we have our expression set up, we can simplify this. So 9 squared is 81 plus x squared equals 121 squared. Then I subtract 81 on both sides and we get x squared equals 40. Now right away, I know that this is not a perfect square. So I know that if I put this in my calculator, I'm going to get a decimal because I'm going to get x is the square root of 40. But we will be simplifying our radicals. When we simplify a radical, we are going to look at the square root of 40 and we're going to break that down. That's the square root of 4 times the square root of 10, which would give us 2 square root of 10. So in this case, x is 2 square root of 10. And this is how we know it's not a Pythagorean triple, because 2 square root of 10 is not a whole number. So even though we can evaluate the side length, which is great, we do want to acknowledge that this is not a Pythagorean triple. So let's try another example. Once again, I'm using my formula a squared plus b squared equals c squared. And I know that 20 is my hypotenuse because it is across from my right angle. So 20 will be c, and then x and 10 will be a and b. Remember, it does not matter what order a and b are in as long as you match up the hypotenuse correctly. So this would be x squared plus 100 equals 400 because 20 squared is 400. Then I can subtract 100 on both sides. We get that x squared is 300. And then I take the square root and we get x is the square root of 300. Now once again, I am going to simplify my radical. So 300 is 3 times 100. And so that would give me 10 square root of 3. Once again, this is not a Pythagorean triple. A Pythagorean triple must have whole numbers. Because this has an irrational number, it has a decimal in it, it will not be a Pythagorean triple, even though we do now know what that length of that side will be. We are going to stop this video here. For more information about the Pythagorean theorem, you should watch the part 2 video. Thank you for watching.